Hello and welcome to the Joinery Business Podcast. The specifics of running a joinery factory can often be difficult with every moving part and choice to make regarding equipment and parts, maintenance and methods. Sometimes it's great just to get advice on these more subtle aspects. This is what our segment Shop Talk is here to speak to, the more intricate and factory-specific issues. Today on the show, Bruce is speaking again to Nigel Newman, a resident factory flow expert. Today, they want to talk about the vacuum pump on your CNC machine. What's causing it to not hold its seal and cause objects to fly off the CNC? How do you maintain this part and why? If you have any questions about today's episode, be sure to jump on over to the Joinery Business Hub on Facebook. Now, without further ado, let's jump into today's episode.
Hey, welcome to Shop Talk. This is a segment where we talk about some specific micro things in a cabinet shop or a joinery business, millwork, commercial, fit out. You probably got a CNC machine or you've got panel saws or something like that in your business. I'm joined here with Nigel Newman, our factory flow expert. And we're going to talk a little bit today about how can you reduce the parts that are flying off your CNC machine because your vacuum isn't holding them down. So Nigel, you've spent a fair bit of time in cabinet shops seeing this problem over and over and over again. Tell us a little bit about, first of all, how do you approach this as a problem? How do you know that it's an issue and we can solve it?
Yeah, so often, typically what you see, there'll be in a nested program, there'll be some smaller parts or long stringers or skinny parts that obviously don't have a lot of surface area for the vacuum table to give purchase to and hold down. What's the first thing the operator does? Turns the speed down on the tool. And that actually is the wrong thing to do. It's actually going to create more forces and more cutting, more pushing, and also the tool's going to heat up more. But the brain just says, hey, it makes more sense to slow the tool down. That'll obviously be less pressure. It's actually the opposite of that. But really what we want to understand is how well is the vacuum table working? Because obviously there's multiple places that you can lose vacuum. It starts with the unions where the hose work is joining. So sometimes I've seen the hose clamp's been lost or removed, and there's maybe a tie wrap or a bit of duct tape, stuck around there.
Because vacuum's a really interesting thing, isn't it? A lot of people don't. I mean, I can't claim that I totally understand vacuum, but there's a point where universal theories or whatever you want to call this, you can only get so much vacuum.
Yeah.
And that's it. There's no more.
Yeah.
And sometimes how we get that vacuum, like even if we talk about dust extraction systems, sometimes opening a port somewhere down in the other part of the factory will get you more vacuum down here.
Yeah.
Which is atmospheric pressures and how they interact with the vacuum.
Yes.
So when we talk about a CNC machine, we're not talking about getting more vacuum, really, are we?
No, we're talking about just having, an even pull on that table. So the vacuum points are pulling at the same rate across the whole table, not higher in the center and lower around the edges. And you actually want to make sure that you're not losing any of the integrity of that vacuum system.
Yeah.
Because there's multiple points where you can start to lose, and it's like a death of a thousand cuts, right? You're losing a little bit here, a little bit there. Yeah. And guess what? This happens over time with any machine.
Yeah.
It starts to deteriorate. And if we're not sure what things to check or how to address those, because sometimes the machine, even when you buy it brand new, you can still actually improve. You can put a bit of seal around the board to make sure you're not losing any vacuum around there.
So let's play a little bit of tennis. You come up with one, and we'll just keep going back and forth with some little gems of how to potentially improve or reduce the amount of parts flying off your CNC machine.
Because it's not always just vacuum. It could be slight reduction in vacuum, but then too much higher tooling pressure because maybe the tool spindle's not cleaned.
Okay.
And there's a bit of vibration coming in from there. So
the first one you said was around the outer edge of the spoil board.
Yes.
That could be edged.
Yep, or sealed actually. First thing is to check, are you leaking there? Are you seeing or hearing?
Well, if it's a MDF, it is going to be leaking there because that's just the nature of the board. It's going to, so let's just assume that if you're using MDF, which most people are for your spoil board, you are going to be losing vacuum around the outer edge of your board.
Yes.
So just seal the damn thing.
Exactly right. It doesn't take long, especially if you have everything to hand. And again, just make it part of that process. When you change that board over, just make sure it's being sealed and have a few minutes to dry.
I've seen some of my clients actually just run it through their edge bander.
Yeah, perfect.
And then when you spoil it, you're taking the edge band down with the rest of the board.
I think Aaron, who's our other team, has said they used to paint the edge.
Just spray it with glue.
Yeah, and you could see it soak in and actually see that it's sealed it. So all these things add up, right?
Yep.
What else you could be doing? So obviously make sure you're cutting it regularly, right? A lot of people that go, because obviously when you skim that board, the first piece, the vacuum is going to be the best.
Yep.
And as you're slowly eating into that board with tool marks, board by board by board, it's actually deteriorating. So if you're going to cut the small parts, if you can, make it straight after you've done the spoil board flush cut, right? Because that's when you're going to have the best vacuum.
Yeah.
That can be sometimes hard to manage, but maybe if you've got a bunch of small parts coming up, you could cut that spoil board.
So this is the second thing, right? So we're going to say make sure your outer edge is sealed.
Sealed, yep.
And the second thing is, your point is that the spoil board itself could be chewed into excessively.
Yes.
Okay, so this is one that I've experienced quite a bit because I used to integrate these machines in cabinet shops. And if we don't have an operator or even the settings in the software accurate enough, we could just be allowing our cutter, which might be set to 0.2 of a millimeter into the spoil board, which is probably acceptable. But in reality, it's going in 0.5 mil.
Yes.
And all that's doing is it's chewing into your spoil board excessively.
Yeah.
Not because it has to, it's because we haven't been dedicated enough to the calibration of our tools.
Yeah.
Or maybe our software isn't reading right to the calibration of the tool. So make sure that your spoil board isn't excessively chewed up.
Yep.
And you may have to recut the spoil board more often than you are right now. That's a good second point.
Yeah, and if you think, what does it take me to recut 4 or 5 parts compared to just giving the spoil board a quick cut?
Yeah.
It probably pays for itself, especially when you do have a sheet that has a lot of small or skinny, strong stringer parts on it.
Yeah.
Other things that can affect parts that have a low amount of vacuum, surface area, so meaning there's not a lot of area to hold them down, can be if your tools aren't kept keen or sharp.
Yep.
So make sure the cutters are maintained.
Yep.
I think you talked earlier, Bruce, about having a simple pot of thinners
Or just a cleaner. Now the safe cleaner to use it. We used to use thinners. We can't do that anymore.
Sure,
it's dangerous.
But some kind of surface cleaning agent that is safe to handle, but can just keep the build up off the edge of that tool, because once that tool gets hot or the build-up's on the edge again, it's going to push more. And if the part is on low vacuum, holding it down, or is a long, skinny part, it's more likely to move that part around. And then people, I want to leave onion skins and want to, extra cuts, and we're just going to move further away from actually fixing the process.
Yeah, that's right. Because we do see a lot of people onion skinning everything just because parts fly off.
Yeah.
Excuse me, rather than actually fixing the parts flying off problem.
Yeah. It kind of helps you cover up that issue. You don't have to worry about it, but it's taking you more time. It's taking you more cutter life, adding more time to the cutting each piece. So, and you don't need to. CNC is quite capable of cutting the right size and the right shape with single pass.
Certainly is. Yes.
But then you have to be careful about maintaining your machine.
Yes.
So these are great machines. They can do amazing things, but you've got to look after them because they're help paying the bills, right?
Yeah. Something that I've seen, I wouldn't say commonly, but I've certainly seen it. When you actually re-spoil your spoil board, you should have a perfectly flat spoil board. And what you can do sometimes, so if you have a machine operator, have a steel measure, a steel
rule,
and just put it on your spoil board.
Yeah.
And if you get, the sawtooth roofs, which is what can happen, because sometimes your actual spindle is not aligned in parallel with your spoil board.
Yeah.
And you can re-spoil as much as you want. What you're getting
lines.
is not flat, and it looks like a sawtooth or an angle, right?
Yeah.
And clearly what happens, you put the board on, you've got all these gaps. You don't have the vacuum you want.
Yeah. It should be the step over where the cutter's taking the cut should be smooth. You should be able to run your finger over it and not really feel anything.
So people will see me if I'm on site and a board, a spoil board has just been done. I'll run my hand over it.
Yeah.
Because you can pretty much tell right away when you run your hand over if it's flat or if it's not flat.
Yeah. Yeah.
Sometimes it'll look like it's not flat, but it actually is.
Yeah. And something I've been talking to clients about is, look, don't make it a guessing game for the operator. The operator is not going to be necessarily highly skilled, and you don't want him measuring, do I need to cut it now? Just work out for yourself, what is the best interval to recut that spoil board?
Yeah.
Is it once a day? Is it every 10 boards? just make it set and forget for the operator so he has consistent quality.
Yeah.
Because who's the first guy you're probably going to go and look at when parts are flying off the table? And you go look at the spot, oh, you should have recut that. And he might say, oh, you were asking me to get all the parts done, didn't have time.
Yeah.
But if you just say, hey, every 10 boards or at the start of shift or whatever that interval is, that keeps that board and the vacuum at its optimized level, then he does not worry about that, and it should be a worry-free process. It should be very repeatable.
Cool. All right. Well, this is good. So there you go. A few little shop talk topics for how to keep parts from flying off your CNC machine.
Awesome.
Thanks, Nigel.
Thanks, Bruce.
Cheers.